Welcome to lesson 5.3, one-step congruence proofs. So we are going to look at our beginning idea of proofs based on congruence, but only proofs that we consider one step, meaning from our first given information or our first conclusion to our final conclusion, there's only one step in between. Now, a justification for a conclusion. So justifying your reasoning, justifying the conclusion you come to, is known as a one-step proof. So let's look at a few pieces of info. So again, if we're doing a proof, as we briefly looked at earlier this year, you create a simple T-chart. On the left-hand column, it's titled your conclusions or your reasons. And on the right-hand side, it's the justifications. And actually, I shouldn't say reasons. It's either your conclusions or your statements on the left, and justifications/reasons go on the right. Now, again, with any proof, the first statement you make or conclusion is what was given to you for information. So what they told us is S subletter K is a size transformation of a magnitude K. So our given info is that S subletter K is a size transformation. Our justification is just given. It was given to us. What can we conclude about line AB and the size transformation of line AB? Well, what we can prove or conclude is that the transformation of line AB is still going to be parallel to the original line AB. And how can I write that conclusion? What justifies that? Well, what justifies that is our size transformation theorem 1. And eventually, for your justifications, I'm fine if you just put the theorem name or the property name or the postulate name. But for now, you'll see in my examples, I'm writing out what they mean, and then in parentheses, I'm giving you the theorem or justification title. So what the size transformation theorem tells us is that any line is parallel to its image under a size transformation. So our justification is the theorem. What can you use for justifications? So what can go in this right-hand column? In the justification column, and this is going to get real ugly, so I'm just going to say them rather than trying to write them here. But what goes in the justification column? What can be justified or used are definitions, are theorems, or postulates. So most of the time in this right-hand column, you'll be using a specific definition, a theorem, or a postulate. Other than the first piece is always what was given to you. So let's move down and look at example 2. Example 2 gives us the given info. Given is that A and B are points in a convex set. So my first conclusion is just restating the given, or my first statement is A and B are points in a convex set. My justification is that that was given to me as a fact. What can we conclude about segment AB? We can conclude that segment AB is in the same set as A and B. So the line AB or segment AB is in the same set as points A and B. How do we know that? It's the definition of a convex set. Well, what does that definition say? It says, if a set's convex, then every point that connects points of the set lies inside the set. So again, this is the long write-out of the definition. Eventually, all you're going to need to put here is definition of a convex set. For this lesson, though, I want you to get used to thinking about what these definitions, theorems, or postulates say. And then we're going to look at example 3, which technically is not one step. It's going to be 2 steps. Given is that triangle QRS is congruent to triangle TUV. So the first conclusion that they gave us, triangle QRS congruent to TUV, the justification is simply the word given. If it's written this way as a prove statement, we're trying to prove the distance of QR is equal to TU. That's always going to be your final conclusion. Whatever you're trying to prove is your final conclusion. Anything in between the first and the final is getting a step closer. So here they told us segment QR is congruent to segment TU. Well, how can they say that? Well, they can say that because of the corresponding parts of congruent figure theorem from our last lesson. We know QR here corresponds with TU here, so any corresponding parts of congruent figures are congruent. So side QR is congruent to TU. Then our final conclusion, QR is equal to TU, comes from the segment congruence theorem. And the segment congruence theorem states, if two segments are congruent, then they are the same length. So because here we establish them as congruent, then in the final step, we can say they're the same length. Now back to a one-stepper here. Example 4 told us M is the midpoint of segment AB. Prove the distance AM equals MB. So I know my given is my first conclusion. M is the midpoint of AB, given. So what allows us to say AM is equal to MB? It comes from the definition of a midpoint, because a midpoint is equidistant from the two endpoints. So M being the midpoint is the same distance A to M as it is M to B. So the justification would be definition of a midpoint. So now let's look at a few different pieces here. Tables of justifications. So on the left here, this table just gives you some common justifications you may be using in these first couple proof lessons. So if you're dealing with segments being congruent, you would want to look in this left-hand column for some things that may be your answer for the justification, such as a definition of a bisector, a definition of a midpoint, corresponding parts of congruent figure theorem, segment congruence theorem, definition of a circle, or definition of congruence. So these are some common justifications you would use when trying to do any proof related to segment congruence. The right-hand column are some common justifications that angles are congruent. Again, these are not all your justifications, but some common ones. So if you're dealing with angles, you would want to look in this right-hand column. And you may be using things like the corresponding angles postulate, the definition of an angle bisector, CP-CF theorem again, angle congruence theorem, vertical angles theorem, or again, our definition of congruence. So as you're going through the proofs, this table's here to help you. You also have those sections in the back of your book that are the different definitions, the different theorems, and the different postulates, which eventually will be a big help as we get deeper and deeper into different types of proofs. Then let's look at examples 5 and 6. So example 5 gave us the given info that lines P and Q are parallel. So I just drew a little arrow in here on each line, meaning the little arrow inside the line, these two lines are parallel. They want us to justify the conclusion that angle 4 is congruent to angle 6. So the solution idea, you want to think about what's given, and then you want to think how are angles 4 and 6 related. Well, 4 is in the bottom left, 6 is in the bottom left, so I know 4 and 6 are corresponding angles. So that might give you a good hint to your justification. So in this case, we would need a reason that tells us angles are congruent, and we'd want to think about which relationship. So the beginning part comes from us knowing these are corresponding angles. What in our table tells us corresponding angles are congruent? If lines are intersected by transversal and those lines are parallel, then the corresponding angles are congruent. So our final conclusion is angle 4 is congruent to angle 6. How do we justify that? The corresponding angles postulate. And again, you'll see I'm not making you write out the whole justification, just the title of the postulate or theorems. And then example 6. In the figure at the right, angle AOB is the reflection of angle COB over line OB. So AOB here, reflection of COB over line OB. Justify the conclusion that angle AOB is congruent to COB. So we know, again, it needs to end with the idea that angles are congruent. So looking at our proof that angle AOB reflected over OB gave us COB was given. That's right up here. The final conclusion that AOB, angle AOB is congruent to angle COB, I would need to, again, look for something that says angles are congruent, and then something about a reflection. Well, if I go through here, I'll tell you right now, there's not the word reflection in this angle column, but there is the word isometry. And reflections are a type of isometry. So the definition of congruence says if an angle is the image of another under an isometry, then the angle and its image are congruent. So what allows us to say angle AOB is congruent to angle COB would be that definition of congruence. So as you go through these proofs, use examples 5 and 6 here as good examples, thinking about this solution process and what you want to think about in your head, and make sure that you use this table here to give you some common justifications.